Okay, here we just need to use a lot of log laws to rewrite some expressions. So we need to use the properties of logarithms to write each logarithmic expression below as a sum, difference, and or constant multiple of single logarithms. So a single logarithm means a logarithm without sums, products, quotients, or powers. So let's have a go at that. It's a bit confusing, but hopefully when we actually do it, it will be okay. So the first one is log base 2 of 8x. Log, this is part A, log in base 2 of 8x. So we have here, we have a product of 8x, so we don't want that. So we can use the laws of logs, even not logs of laws. So we can say the first law, we can use that to split this into a sum of two logs. So that could be log base 2 of 8 plus log base 2 of x. So log base 2 of 8, remember that's the power you raise 2 to in order to get 8. So log base 2 of 8 is 3 because 2 cubed is 8. So this now is 3 plus log base 2 of x, and you can't really do a lot else with that, but we have expressed it as a sum of simple logarithms, and here just a number. So we don't have a power or a quotient or a product in the log. Right, part B, ln, so natural log, log base e of 3 over y. Again, we can use the second law of logs now to write this as a difference of logs. So this can be equals ln 3 minus ln of y. So remember, natural log, log base e. You've now written that as a difference of two simple logarithms, and you can't do anything else. Part C, log of root 7. So log means log base 10 of root 7. So here the problem with this is we have a power, so a square root is a power of a half. So that could be written as equals log of 7 to the half. And the third law of logs says that you can, if you want to, you can bring the power to the front. So we can call this equals 1/2 log 7. So what we've done, log 7 can be classed as a simple log. So this is a constant multiple of a simple logarithm. Just a half, constant multiple, simple logarithm, log 7. Part D, log in base b of x cubed over y squared. X cubed over y squared. So here, you're definitely going to be looking at the second law, which is the differences. So we can write this as log base b of x cubed minus log base b of y squared, so like that. Which it's a bit. It could be argued it's a bit better depending on what you want it to look like, really. But we're still going to have to get rid of the powers, because we've been specifically asked to not have any powers in there. So we're just going to use the third law, move the 3 to the front, move the 2 to the front. So now this is going to say equals 3 log base b of x minus 2 log base b of y. Okay, E. Natural log of 5e squared, so ln of 5e squared. Now, I'm going to do these all, you probably hopefully noticed I'm doing all of these step by step. In practice, you might take 2 at a time. I'm never going to do that, because I don't think that's my job to do that, really, but you can if you feel comfortable and you don't get it wrong, of course. So what I'm going to do, I'm going to apply the first law first. So what I mean by that is I'm going to split this into a sum. So I'm going to say this is ln 5 plus ln of e squared, like that. Then I'm going to just use the third law on the second one, so I'm just going to bring the 2 to the front. So that equals ln 5 plus 2 ln e. And now if you think about ln e, you remember ln is log base e. So this is saying, if we just ignore the 2 for a minute, this is saying the power you need to raise e to get e. Well, that e to the power 1 is e. So ln e is just 1. So this now becomes ln 5 plus 2. Okay, part F. I'll do F down here. Log, so log base 10 of m plus n over n. So this is, I think the reason why this is there is to kind of entice you into making a common misconception. So you might be tempted to look at that and try and misapply some laws. There's not a great deal you can do with this other than apply the second law. You can say, well, this whole thing is a quotient. So all you can really do is say, well, this is log of the top minus log of the bottom. So this is equals log m plus n minus log n. And then so many people would get something like this in the exam and they try and do things, they try and turn this into sort of maybe log m plus log n, or even you'll see a lot of log mn, so sort of applying a backwards reasoning that really doesn't work. You can't do anything else with this, unfortunately, so we are going to leave it like this. But we have met the objective because we've got simpler logs, so it's a difference of logs, and there are no products or quotients or powers in the answer, there's just a sum, so that's okay.